Peace be unto you and your family. 12th Chemistry Refresher Course Module Unit 4 Periodic Table and Periodic Properties. So, after learning this video, you come to know about define modern periodic law, name the elements with atomic number greater than 100 using IUPAC nomenclature, classify the elements into S, P, D and F black, explain the periodic properties, explain the anomalies in the expected trend in the periodic properties. First, we will discuss one by one modern periodic law. We know the physical and chemical properties of the elements are the periodic functions of their atomic number. If the last word is atomic weight, it is called the Mendeleev periodic law. This is atomic number, modern periodic law. Modern periodic table, we enter into the overall view. The long form of the periodic table is based on the modern periodic law. In this table, the elements have been arranged in the order of increasing atomic number. Nomenclature of element with atomic number more than 100 using IUPAC notation, how to give name of the element. The name was derived directly from the atomic number of the element using the numerical roots. The numerical roots corresponding to the atomic number are put together and add IUM as suffix. At the end, the name of the element is end with IUM. Then the final N of ENN, N atomic number 9, is omitted when it is written before nil. N plus nil equal to this last N is omitted, En nil. N is also omitted. Similarly, the final I of bi and tri is omitted when it is written before IUM. Bium I is omitted. Trium I is omitted. The symbol of new element is derived from the first letter of the numerical roots. Now come to the notation for IUPAC nomenclature of element, digit. For 0, the root is nil, 1 and 2 by 3 tri 4 quad 5 pent 6 hex 7 sept 8 oct 9 n. And the abbreviation first letter N, U, B, T, Q, P, H, S, O and E. See, all the abbreviations are different abbreviations. Now, name of the element with atomic number above 100. Atomic number 101. First one means the root word is un. First one means the root word is un. Then second for 0, nil. Third for 1, un. The name of the element end with IUM. So, un means 1, nil means 0, un means 1, name of the element end with IUM. The first letter from un, U, and the second abbreviation N, third abbreviation U. Temporary symbol UNU. Name of the element actually Mendeleevium. Symbol MD. 102 un nil bium UNB. When you write bium, the one I is removed. UNB. Nobelium NO. 103 un nil trium. Here also one I is removed. UNT Lawrencium LR. Then structural features of periodic table. There are two important structural features of periodic table. One is group, vertical column. There are 18 groups in the periodic table. And periods, left to right, horizontal rows, 7 periods. Characteristics of group. All the elements present in the group have same general electronic configuration and have similar chemical properties. Characteristics of period, horizontal rows. In all the elements present in the period, the electrons are filled in the same valency cell. First period, the electrons are added in the first cell, second period, second cell, and goes on. Classification and characteristics of elements. Elements are classified into orbitals S, P, D, and F flag element. We know the maximum number of electron in S orbital 2, P orbital 6A, D orbital 10A, F orbital 14. S black element. The elements of periodic table in which the last electron entered into S orbital are called S black element. They have the general electronic configuration NS1, 2. Alkali metal NS1, first group element, alkaline earth metal, second group element, general electronic configuration NS2. The S black elements are, first one is soft metals. They are highly reactive. They form ionic compound and they impart color to the flame. Come to the second black element, P black element. The elements of periodic table in which the last electron enters into the P orbitals are called P black elements. They give general electronic configuration NS2, NP, 1 to 6. This P black element consists of metal, non-metal, and metalloid. They are present on the left side of the periodic table. The compounds of these elements are mostly covalent in nature. They show variable oxidation state. D black element. The elements in which the last electron goes to n-1 d orbitals are called D black element. They are also known as transition element because they form transition between S and P black element. The properties of T black element, the properties of D black element is in between the properties of S and P black element. Therefore, they are also called the transition element. The general electronic configuration of D black element is NS1 to 2, n-1, D1 to 10. It consists of 4 transition series. Each series consists of 10 elements. First transition series starting with the scandium atomic number 21, ending with the zinc atomic number 30. Second transition element starting with the yttrium atomic number 39, ending with the cadmium atomic number 48. Third transition series starting with the lanthanum. Between lanthanum and hafnium there are 14 elements are missing. Atomic number 57, 72, 80 mercury. These 14 elements are placed under F black element. Fourth transition series starting with the actinium atomic number 89 and rutherfordium to cobernicium 104 to 114. These 14 elements are arranged under 5F black element. Most of the transition elements are metals with high melting and boiling point, paramagnetic, forms colored ion, exhibit variable oxidation state. F black element. The elements in which the last electron enter into n-2 F orbitals are called F black elements. They are known as inner transition elements because they form transition within the transition element. They are further classified into lanthanoids, 4F black element, general electronic configuration 4F 1 to 14, 5D 0 to 1, 6s2, and actinoids 5F black element, 5F 0 to 14, 6D 0 to 2, 7s2. Most of the F black elements, their properties of elements are quite similar in nature. Actinoids are radioactive in nature. Then periodicity and its property. The repetition of properties of elements occur at regular intervals is termed as periodicity. Reason for periodicity is due to the similar electronic configuration. There are 4 important properties, periodic properties. They are atomic and ionic radii, ionization energy, electron affinity, electronegativity. Atomic and ionic radii. The distance between the center of the nucleus to the outermost cell of an electron in an atom or ion is called atomic radius. Unit is angstrom. 1 angstrom equal to 10 power minus 10 meter. Trend in periodic table. Atomic and ionic radius in period decreases because electrons are added to the same energy level. In group, atomic and ionic radius increases because the valence electron present in different orbit. Come to the next periodic properties, ionization energy. Amount of energy required to remove the most loosely bound electron from an isolated neutral gaseous atom is called ionization energy or ionization enthalpy. Unit for ionization enthalpy is kilojoule mole power minus 1 or electron volt. Metal in gaseous state lost 1 electron and becomes a monopositive ion. The energy required is called first ionization energy. From monopositive ion, the second electron is removed and it becomes a dipositive ion. The energy required is second ionization energy. From dipositive ion, 1 electron is removed and a tripositive ion is formed. The energy required is called third ionization energy. Remember, successive ionization energies are in the order of first ionization energy value is less than second and third and goes on. Trend in the periodic table. Ionization energy in period when you move from left to right increases, in group decreases. Then the next periodic property is electron affinity, formation of anion. Electron affinity. Amount of energy released when an electron is added to the valency cell of an isolated neutral gaseous atom is called electron affinity. Unit kilojoule mole power minus 1. An atom in gaseous state gain 1 electron becomes a negative ion. The amount of energy released is called the electron affinity. In periodic table, electron affinity, when you move from left to right in period increases, top to bottom in group decreases. Come to the fourth periodic properties, electronegativity. Relative tendency of an element in a covalently bonded molecule to attract the shared pair of electron towards itself is called electronegativity. It has no unit. Trend electronegativity in period increases, group decreases. The most electronegative element among 118 element is fluorine. Second most electronegative element is oxygen. Factors affecting ionization energy and electron affinity. Ionization energy and electron affinity inversely proportional to atomic size of the atom. Ionization energy is directly proportional to nuclear charge. Ionization energy is inversely proportional to shielding effect, and this is screening effect. S orbital has more screening effect than P, than D, and F orbital has very poor screening effect. Electronic configuration is also affect the ionization energy and electron affinity. The elements having completely filled electronic configuration and half-filled electronic configuration are more stable and has high ionization energy and zero electron affinity. Anomalous properties of second period elements. Diagonal relationship. On moving diagonally across the periodic table, the second and third period elements show certain similarity. Diagonal relationship, for example, lithium, magnesium, beryllium, aluminum, boron, silicon are diagonally. Some of these properties are similar in nature. In this video, my dear students, we discussed about periodic table and periodic properties. Thank you for watching. If you like, please subscribe. Thank you very much.